A body is moving in a straight line. When it is s meters from a fixed point O on the line, its velocity v is given by v equals negative 1 over s squared, where s is greater than 0. Find the acceleration of the body when it is 50 centimeters from O. Okay, so the first thing to notice here is that s is the displacement from the point O, and so we know that the velocity is equal to so I'm just going to write down the relationship between the velocity, the displacement, the velocity, and the acceleration. So the velocity is just the derivative of the displacement with respect to time, and the acceleration is just the derivative of the velocity with respect to time. Okay, and so we're going to use the expression we have for velocity that's given to us here, and we're going to differentiate that. So we know that the acceleration is the derivative of the velocity with respect to time. So let's do this. So d over dt, I'm just going to write this in a better form. So you should notice that that's just the power rule. So the negative 2 comes here, that becomes a 2, this becomes a negative 3. So we have a 2s to negative 3, but we are differentiating over t, so we need to apply the chain rule and take the derivative of s over with respect to t, I mean. And so we have that. I'll just write that in a better form. So 2 over s cubed times, and ds over dt, should notice, is ds over dt is equal to the velocity, and so that's equal to the velocity, and we know what the velocity is. It's just negative 1 over s squared, so we can actually just substitute that in. So we will have negative 2 over s to the 5 if we substitute this in for here. Okay, and now they're asking us to find the acceleration of the body when it is 50 centimeters from O. Okay, so there's a little bit of a trick here, 50 centimeters, and you'll notice that here it says s meters, and so we need to convert this to meters, and so just divide that by 100. 50 centimeters equal to 0.5 meters, and now we can substitute that in. So we'll get negative 2 over 0.5 to the power of 5, and that is our acceleration. And since this is paper 1, you don't have a calculator, you can't really evaluate this, and so I think it's okay if we just leave it like this, and there's your answer.